Thank you. Thanks for coming. So this is actually the third year we've done like an API landscape overview. The good news is that things keep changing fast enough that it's worthwhile to keep doing it. There's lots of new things to discover. But also looking back at the previous presentations, most of what we've been talking about and predicting is kind of coming true if you're keeping score at home. Mentioned, I'm working for the Khronos group, so we'll mention some of the Khronos APIs because we have some new developments to share with the community here. But we're going to try and keep this very much not a marketing pitch for Khronos, but rather give a unbiased view of the landscape. So, as we look at the various APIs, one trend is definitely stronger and getting stronger each year. We do this overview, and that is the layering of the ecosystem. There are problems to be solved in terms of the programming of these advanced processors that no one standard or API can address by itself. So we have at the bottom an increasing amount of diverse hardware, everything from GPUs, FPGAs, DSPs, now tensor processor units, dedicated hardware of various shapes and sizes. And the aim of all of these software tools and libraries and APIs we're going to be talking about is to provide high performance on this set of silicon, ideally in a portable way. So we can take our software investment and take it across the different processors in the industry with the minimum of cost. So if you go up through the layers, we start with intermediate code representations. This is the low level, close to the binary code that typically is generated by compilers. We separated them out as a layer because the software and compilation tools are becoming increasingly central to delivering high performance vision processing. In the next level up, we really have the kind of the core of the ecosystem in some ways as the explicit APIs, like OpenCL and Vulkan, which is a GPU API. These are the APIs that don't try to give you any performance portability. You're coding to the metal. You get to control what runs where and how. But it's often used by the higher levels as a target rather than trying to target individual pieces of hardware. So you can get some portability that way. Above the explicit APIs, we have increasingly a set of languages and tools that are leveraging ISO C++. The standard C++ programming language is being exposed by layers like NVIDIA CUDA, C++ AMP, which is a Microsoft C++-based library, and SYCL, which is the Khronos single source C++ solution. And we'll compare some of these. And then on top, we have the kind of the domain-specific libraries. These are the libraries that are looking at neural network acceleration or vision processing. And kind of the other kind of thing that's really it's kind of obvious, but it's kind of becoming more obvious, is that pretty much all of them now are using graphs. The graph abstraction is really powerful for the two use cases that we care about most here, and that is vision processing and neural net acceleration. So let's start looking at OpenVX, which is one way of doing graph programming, and then we'll look at some others and see how they compare and contrast.